right. I think first of all, thank you everyone for staying, and not sleeping. Appreciate that. And first of all, as a closing speaker for today, I would like to give a shout out to Vocamo, to Confluent, and Snowflake as well for sponsoring, hosting the event, and organizing as well. Thank you. So yeah, before we start, okay, all right, it doesn't show up. All right, yep. So today I'm going to give a talk about you know Iceberg Go and the table maintenance and how we are heading towards the table v3 specs as part of the main Java project. This is the pictures that I put it on ChatGPT and it just came out nicely. Yep. So a little bit of myself. I didn't put the pictures obviously, but you can see me in person, so that's nice. My name is Tung, T-U-N-G. In my day-to-day work, I work as a data engineer for one of the local company here. In my 5 to 9, as the TikTok trend always says, I'm an active open source contributor, and I contribute usually to quite a number of projects. But currently, I focus on 2 projects. One is the Iceberg Go project, which is part of the bigger Apache Iceberg project, and also the second one is the KDA, which is also part of CNCF project. It uses different signals to auto-scale your Kubernetes workload, and I'm part of the reviewer/maintainer of the projects currently. Yep. With that in mind, let's talk about a bit about different implementations of Apache Iceberg. As you all know, Apache Iceberg is mainly written in Java, but as different people, they have different appetite for programming languages, and also different company, they have different preference for their own languages used internally within the company. So as a result, we have Iceberg, PyIceberg. We have Iceberg Rust, which is currently very actively contributed and maintained as well. We have Apache Iceberg Go and C++ as well. So that is the list of all of the project. So the next question is why Go and why Iceberg? So we can divide it into 2 different part of the answers. One is the ease of developments, and the other one is ease of deployment. And all of this is very subjective, so take it with a grain of salt if you want. So the first one is it compiled to native code. Sorry, I couldn't see it here. So and it's very simple and easy to learn and not as complicated as. Can I use that as well? Thank you. It's a lot easier. Yep. So it's very simple and easy to learn. Unlike other languages like C++ and Rust. I'm comparing languages here, so yeah, it's fine. Also, concurrency is designed with a first-class citizen when it came out Google's, because Go routine is support multi concurrency very nicely, and because it is Go came out Google, so there's a vibrant communities and ecosystem that revolve around Golang. The next part is ease of deployment. So because it compile nicely into binaries, you can build it with multiple architectures like AMD 64, ARM 64, or even Windows, and you can deploy it anywhere without any external dependencies. It also very fast. It is subjectively fast, so yeah, that's kind of the reason why we should go for Go. About the next slide is the current state of the Go implementation for Apache Iceberg. We divide it into 3 different sections: the catalogs and files. For catalogs and files, we support REST catalogs, SQL catalogs, glue catalogs, and most operations are supported as well for For storage-wise, we support S3, we support GCS, we support Azure Blob Storage. We also support local storage as well, if anyone is interested developing locally. For read support, there's reading schemas, snapshots, metadatas, and the interesting things about Iceberg Go is that because it's non-JVM, we leverage on Apache arrows to read the actual data from the files. And because of that, we support scan planning, positional deletes, read repetitions. And recently, we launched our features of time travel query, which arguably is one of the features that make Apache Iceberg famous, and a lot of people are leveraging on that. So for write support, currently it supports creating new snapshots, new namespaces. We can append existing data files onto, and also appending the stream of data, rewriting, deleting files. Sorry, I missed out one of the part on the read support is that currently we only support Parquet files. Other formats is not currently supported yet, but if you want to make that supported, please feel free to contribute to the project as well. Yep, so let's make it a bit hands-on and lightweight, and try to do the same thing with slightly different, right? So in the next example, next example, I'm gonna try to read a catalogs, read the tables with a piece of Golang code. From here, you can see that you can specify your REST catalogs, your endpoint location. In this case, is just localhost 8181, and the rest of it is just the S3 username and password. This is for internal developments, local developments with min.io. So we are not expecting you to hard code your username password into the code, but you get the idea. So next one, we're just going to load the tables. In this case, the table we specified is default tables and default namespace and test all types tables. And from there, you can just print out the table locations. If you run the code, it's going to come out like S3/warehouse/default test all names, test all types. To be back. Yep. So because we are using Golang, it's also possible to make it as a CLI command. You can run it on your terminals without writing the codes, because sometimes it's faster for developments or like for testing out and debugging stuff, instead of do some complicated JVM Java stuff. So in the query, although it's a little bit small, it's the same thing. We specify REST catalogs, your endpoint, the table names, and just print out lots and lots of information about the schemas, the table properties, and also what is the snapshot version as well. All of this is available in the documentations of Iceberg Go project. So if you like to check it out, you can see it. What time are we now? I promise I will get everyone back on time. Yep, so on the table maintenance, so before we deep dive on what is table maintenance, we have to answer what it is. So table maintenance is actually some kind of a background or admin task that you can write to keep your tables performance fast and optimized and consistent as the data evolve and keep adding more and more data into your systems. So as mentioned in the official docs of the Apache Iceberg, there are currently 5 different operations that you can perform. Most of it is either touching on the metadata layers, or they're touching on, like metadata layer, like expiring snapshots, or like removing old metadata files, or rewriting your manifest file. And some other operation, they are touching on the actual files like table compactions and deleting orphan files. Yep, so as of now, the Iceberg Go project support expire snapshots and delete orphan files. For the other trees, we are actively working on it, but we need more people, so yep. Due to the interest of time, I'm going to just deep diving into the delete orphan files operations because it's just been recently implemented. I just want to get it out and share it with the communities. What causes orphan files and why do we have to do that? So orphan files is actually, it happens when you have write operations, for example, like a Spark pipelines or Flink pipeline that's writing data into Iceberg, and there's some kind of failures, and it leaves your data files in a hanging state where it is not tracked by any manifest file or manifest list. It can also causes by the limitation of snapshots expirations. So if it was never be part of any snapshots. So if you do a snapshot expiration and it will not clean up any of the redundant hanging file or in limbo states because it's not tracked anywhere in your systems. And also there's a limit on metadata file management. So there's some kind of config that when you set it to be true, and Iceberg just maintain a list of the number of version that is going to be tracked. So besides that number of version, everything is going to be orphan and then it's not going to be tracked anywhere in the system. And that is why we have to do some kind of admin work to clean it up and saving on the builds and performance of the tables. Yep, so in here, this is a snapshot of the code that we can write to run table maintenance operations. So there are 3 different ways, not just one different way, but many different options. You can run it with a dry run flag to see how it's going to be. You can specify some kind of config to see that, hey, I want to clean up files that is older than 7 days. Whatever files that is, earlier than 7 days, I would not be touching on it because there might be the data file might be very new and we don't want to accidentally delete any data file. And also we can specify a lot of others options like with locations, equal scheme, prefix mismatch mode, and some kind of delete functions that you can support. I'm going to talk about it in the next slides. Yep, so the next slides deal with a lot of the configs in great details. I have to go here to see. So for the locations, right, you can specify a specific S3 path or so the purpose of it is that sometimes you want to clean up a specific path in your S3 buckets like /data or metadata / so that you keep the other one untouched. The other one is that I mentioned earlier is older than, where you only want to deal with data of a certain age, like longer than 7 days, longer than 14 days. It depends on your company's specific needs for that. The next one is the delete with option. So sometimes you want like a customized UDF functions that deal with the delete data. And for that, you can specify it. You can create your own functions and put it in there with this delete with options. Okay. Yep, so the next one is a little bit more on cloud options. Like, first of all, is the equal schemes. So the purpose of that is sometimes you have different schemes like S3, S3A, S3N, and it all means the same thing, right? So You want to tell the program that, hey, although the prefix might be different, but it just means the same file, the same path to the files, and you should treat it as equal. The next one is the same thing, a little bit different as well. It treats different URI authorities like HDFS, cluster 1, cluster 2. All of this is basically laid out in the Apache Iceberg specs on Java specs. So we are just following that. So what happened when you deal with mismatch on the files? You have various options. You can try to error out the one that you found, or you can ignore it, or can try to delete the one that is mismatched. So it's up to you to configure as well. Yep. Speak too fast. Yep. So this is a little bit of the progress that we are doing on the V3 Iceberg table specs. So as you've read all of the V3 that came out, it can be divided into different sections. First of all is the new data types. The second one is the deletion vectors, row lineage tracking that I think Anton talked about when we're trying to adopt Iceberg CDCs, and it's going to be very, very important to, to be maintained in the next coming version of the table specs. Also about default value of columns and then multi-argument transform. So all of that is laid out here, and as you can see, we are getting on track, but the progress is still that great, and we hope to get it out sooner or later. So because the community is already working on V4, and we do not want to be lagging behind, so far behind. Yeah, so that's why we are always looking for new contributors. Our project is quite young. It's only came out of in September 23, so which is a little bit more than 2 years now. So this is the commit graph of it, and yeah, so we're always looking for new contributors who are interested in working on the low-level stuff, trying to understand about Apache Iceberg ecosystem, while take pride in working with Golang. All right, so with that in mind, I will end my presentation right on the dot of 8:30. All right, cool. Thank you very much. Sorry, any questions? All right. Yep. What do you mean by number? It's just the language in general, yeah. So you can find a lot of comparison online for that as well. Thanks.
Cool. Any Go developers here? No? Oh, there's a potential contributor for you.
Yes.
Okay, Tung, thank you very much. It was nice. And applause to Tom. And I just want to close our meetup. Thank you for everyone who was online, listening and asking. And thank you again to Confluent and Snowflake, and probably Snowflake want to say some closing words.
Oh yeah, I was just going to say the same. I will finish up the recording online now. So thanks everyone for joining who's online, but you're about to go on mute.